Hello viewers, I am Kausalya. Today we are going to solve problems related with RLC transients. The problem is a series RLC circuit with R equal to 5 ohm, L equal to 0.1 Henry and C equal to 500 microfarad has a DC voltage of 100 volts applied at T equal to 0 through a switch. So find the resulting current transient. So here the value of R, L and C are given as well as the source voltage is given. So this is how our circuit diagram will look like, right? So the first step is we have to apply KVL. So KVL is nothing but sum of voltage drop is equal to sum of voltage rise. So here the voltage drop is nothing but that is voltage drop across resistor is I into R, inductor is L into di by dt and capacitance is 1 by C integral of I into dt, right? So here just substitute the values accordingly. I into R plus L into di by dt plus 1 by C integral of I into dt, which is equal to 100, right? The next step is we are going to take Laplace transformation. So here this I becomes I of s, di by dt becomes s into I of s, and here this integral of I into dt becomes I of s by s. Right. Here in this case, I am shifting this 10 to the power minus 6 to the numerator part. Therefore, it becomes 10 to the power plus 6 divided by 500. Right. Once you cancel, we are getting the answer as 2000. Right. So, the remaining terms remain as such here. The next thing is we are taking I of s commonly outside. So, once you take I of s outside, this is how our expression is. Right. Now the next thing is we are going to take LCM for these terms. So once you take LCM here, our expression will be like this. 5s plus 0.1 s square plus 2000. Right. Now here both the denominator terms cancel each other. And finally the expression for I of s is 100 divided by 0.1 s square plus 5s plus 2000. Right. So here again the standard format is we should be only having s square. But here we are having a term 0.1. Therefore we are dividing or we are taking the 0.1 commonly outside. So when you take 0.1 outside, what does it mean? That we are dividing this entire denominator by 0.1. Right. So what happens? S square plus 5 divided by 0.1 becomes 50. 2000 divided by 0.1 becomes 20,000. Right. So again 100 divided by 0.1 becomes 1000. So this is the expression for I of s. But what we actually need is expression in terms of I of t. Right. So the normal method is we have to find the roots of the denominator, right? Then by using partial fraction, we have to find the values of constants, and then at the last step, we have to take inverse Laplace transformation, right? But here in this problem, we are doing quite different. That is, you see, here we are having s square plus 50s, right? So here we are considering these terms as, that is s square plus 2ab in the form of like this. That is, we will be having, right, a square plus 2ab plus b square. Yeah, similarly, we are trying to remake this expression in terms of this, right? So here in the place of a square, we are having s square, and in the place of 2ab, I am having 50s, right? So here the value of a is 1. Right. So 2ab is nothing but 50 here. So 2ab is 50 and the value of a is 1. Therefore, the value of b is 25. Right. So again we are, the 25 square is nothing but 625. Right. So 20,000 minus 625 will be 19,375. That is, we are splitting this 20,000 as 625 and 19,375. Right. Okay, I believe these are all the basic things which you would have done in your marks. Now, I am combining these three terms as s plus 25 the whole square plus I am taking square root as well as squaring the same number so that its value remains the same. So here squaring, okay, squaring as well as square root is done. Now, you see the square root of 19375 is nothing, 139.2. Right. So after arriving at this kind of expression, again you have to multiply and divide by the number which is present here, right? So everything is done for a purpose, right? So you see the expression is multiplied and divided by this 139.2. So 1000 divided by 139.2, that gives an answer of 7.184, and here the remaining numbers, they remain as such, right? Now we are going to take inverse Laplace transform directly, because once you have an expression like this, there is a formula in inverse Laplace transformation, okay, which makes our work quite easier. So here in this case, you see this expression, when it is taken inverse Laplace transform, we are getting e to the power minus 25t into sine of 139.2t. Right. So here you see this is the expression, right? So when you have expression like under this format, then their respect to f of t is given by this value. Right. So here you see in the place of omega we are having 139.2, and again in the place of a we are having 25. Right. Therefore the expression is e to the power minus 80. Therefore e to the power minus 25t into sine of 139.2t. Right. So finally this is our expression for transient current. Right. Now we will proceed with the next problem. Our next problem is a step voltage V of t is equal to 100 U of t is applied to a series RLC circuit with L is 10 Henry, R is 2 ohm and C is 5 farads. The initial current in the circuit is 0, but there is an initial voltage of 50 volt on the capacitor in a direction which opposes the applied source. Find the expression for the current in the circuit. Right. So here as usual, RLC values are given. The voltage is in the form of step voltage, right? That is unit step voltage. That is here again the value of U of t will be 1. Therefore the value of source voltage is 100 here, right? Now here the different thing is the capacitor, it has an initial voltage of 50 volt in the direction which is opposite to that of your source voltage, right? That is the key thing to be noted here. So the remaining things hold as such. So first we are going to apply KVL. Right. So we are having R, L and C. Since the capacitor has some initial voltage, we are splitting and writing the expression as like this. That is, this denotes the initial voltage across the capacitor. Right. So 1 by C integral of minus infinity to 0 I into dt, plus here 1 by C integral of 0 to t I into dt. Right. So here this term represents the initial voltage. So what is the initial voltage given in the problem? It is nothing but our 50 volt. Right. So here again these are all the respective voltage drops and this is your voltage rise. Substitute the respective values here. Right. Now you see here we are having a number 50. So I am moving this 50 to the right hand side. Therefore here our expression is like this. Right. Now the next thing is we have to apply Laplace transformation. So once you apply Laplace transformation, you see 2 into I of s plus this di by dt becomes s into I of s and this integral term becomes I of s by s. Right. Now the next thing is we are going to take this I of s commonly outside. So once you take I of s outside, our expression will be like this. Right. Now the next thing is we have to take LCM. So once you take LCM, our expression is, you see, that is 10s plus 10 into 50 becomes 50s square plus 1 by 5s, which is equal to 50 by s. So here both these denominators cancels each other and the expression for I of s is given as, you see, that is 50. Here we are having a 5, right? So when you just bring this to the right hand side part, what happens? We have to keep it as a reciprocal, or this occupies the denominator term, therefore the 5 will get multiplied with the numerator, or simply you can take just cross multiply. Okay, everything is fine. So therefore 250 divided by 50 s square plus 10s plus 1. Again our basic rule is we should be having only s square, right? Therefore we are going to divide this term by 50, or we are taking 50 outside. Okay, everything is fine. So once you take 50 outside, you see, this is how our terms will be. When you further simplify, okay, our expression will be like this, right? So again, okay, Rather than finding the roots of this quadratic equation, we are trying to make this quadratic equation in the format of like this. That is s plus something the whole square plus a number the whole square. Right. So here again the same thing. This is the 2ab. Therefore 2ab is 0.2. The value of a is 1 because the coefficient of s square is 1 here. So 2 into 1 into b is 0.2. Therefore the value of b is 0.1. Right. So we should have, that is, the expression should be like this: s plus, that is a plus b the whole square. A is s and the value of b is 0.1. Right. So a plus b whole square. So when you subtract this 0.1 square value from this term, here we will be having again 0.1 whole square. Right. So this is quite simple. Right, we are splitting this point R2 as 0.01 plus 0.01. That's it. Right, the 0.01 is written as 0.1 whole square. Right, now again you see what is the thing, we have to multiply this number. Okay, we have to multiply and divide this number. So when you multiply and divide by this number, you see 5 divided by 0.1 becomes 50, and here we are having the remaining terms: 0.1 divided by s plus 0.1 whole square plus 0.1 the whole square. Now it is very easy for us to apply inverse Laplace transformation. So when you apply inverse Laplace transformation, the expression will be, that is 50 into here s plus a, right? Therefore e to the power minus at. So e to the power minus 0.1 t into sine of 0.1 t. Right. So this is the final answer for this problem. Right. So if you have any doubt, let me know in the comment section. Thank you.